Hi, my name is Erin. I'm a doctoral student in the Boston University School of Public Health in the Environmental Health Department, and I'm going to be presenting on my urban internship that I did with HEAT, the Home Energy and Efficiency team, on visualizing modeled spatial patterns of residential heating consumption and efficiency in Massachusetts. We are experiencing global warming which means we are seeing increased temperatures and more extreme weather events. And a significant contributor to global warming is our greenhouse gas emissions. Fossil fuels significantly contribute to greenhouse gas emissions. So transitioning away from fossil fuel infrastructure, such as natural gas or oil and propane, is a primary solution for climate change mitigation. So Massachusetts has a clean energy and climate plan with climate goals that include achieving net zero building emissions by 2050 and reducing overall emissions. I sought to work with HEAT, the Home Energy and Efficiency team, who is helping to achieve this energy transition in a just and equitable way. They are looking to focus on low-income and environmental justice communities who are more likely to be energy insecure, so might have more trouble paying the energy bill, and are looking to replace fossil fuel energy or heating infrastructure with a more sustainable option, particularly geothermal, and they are doing this through a gas to geo project. So a little bit about geothermal and what HEAT is trying to do. So geothermal is a sustainable energy source that takes advantage of the constant temperature from underground, from shallow bedrock or water bodies to heat and cool buildings. And so holes are drilled in the ground and pipes are installed and water is flow through these pipes to sort of pull heat up into the building in the wintertime when it's cold and to dump heat into the ground in the summertime when it's hot. And so what HEAT is looking to implement are our geothermal districts, so kind of connecting geothermal lines in a network that allows buildings to not just pull energy from the ground, but also energy and to exchange energy from each other as well. And so in order to achieve this transition and to make this transition in a just and sustainable way, we need to identify spatial disparities in energy. So where might we be experiencing energy insecurity in the state? And so two key spatial disparities are energy consumption, how much heating we're using, and how much and intensity, which is how efficient is the heating that we're using. So I took household energy data from the Residential Energy Consumption Survey, and I used that to find the patterns and the associations between housing characteristics and energy patterns. And I applied that to state level data in order to model the relationship between housing characteristics and heating consumption at the state level. As part of this internship, I was also working with the Institute for Global Sustainability that helped fund this project. And I presented at their poster session, sort of showing preliminary results that I had on the housing characteristic data, significant predictors of energy consumption, and how we use our fuel heating in the state. And so what I've enjoyed so far has really been just getting to know the HEAT team, really being able to connect with other professionals in my field who share similar passions and interests, and which kind of gives me hope to push this forward into a publication and potential for policy recommendations as well. So I just want to acknowledge the collaborators that I've been working with and my funders as well for this program, and thanks so much.